evening, Doctor. We are from English College, and our research project to go to Singapore is Nano-Enhanced Electrolyte, which means we are going to enhance the current general electrolyte there is with nanotechnology, so we can improve the hydration, so that the athletes or the active people who needs their hydration and energy will become better lah. So that means with this nano-enhanced electrolyte, they can improve their hydration and their mineral intake so that they can perform in their training for athletes and their daily life activities such as working. So we have some questions to strengthen our research before going to Singapore, and we would like to
Mm-hmm.
ask you about your opinion on it.
Okay.
So can you please?
All right.
Okay, so the first question, what do doctor understand by the nano-enhanced electrolytes?
Okay, when we talk about nano-enhanced electrolyte, okay, electrolyte example like sodium, potassium, okay, you can, you can digest it, okay, to produce electrolytes in your body. Okay, so nano means that so far what I understand from your topic is actually we make anything that from micro scale to a nano scale so it can have a better absorption towards your body.
So, thank you, doctor. So, shall we proceed to the next question? Okay, so Dr. Ting, could nano-electrolytes be more effective than the normal electrolytes in the future? If yes, in which aspect?
Okay, when we talk about nano size, okay, before we proceed to that question, nano size is actually smaller size compared to micro or even macro, correct? Okay, why we want to have a nano size? Because we want to have higher surface area, correct? Okay,
Yes.
so obviously nano will be more effective as compared to normal electrolytes in the future. But however, from my perspective, if we want to use in living human, living thing lah, such as human, you have to consider about toxicology test, in vivo test or in vitro test. Okay, understand about that, eh?
Right, so, okay, the third questions. Could you give us some of the suggestions on our study plan and our research?
Okay, okay, my advice. There's a lot of advice that I can propose to you. Okay, first things first, this you want human to consume, correct? Which is actually
Yes.
okay. Before you proceed to that, if you want to make as a prototype or even if you want to test on a living thing, you have to know about toxicology test. Okay, toxicology test, example, you have in vivo, in vitro. So you have to go through that. Okay, if you want to use in a living human. Um, and then further testing you have to do lah. There's a lot of qualitative and quantitative tests that you need to do before you do this as an actual project. That is from my perspective. Okay.
Right, so I should proceed next. In your opinion, is there a big possibility for us to make this technology successful?
Oh yes, it is actually very possible, and it's a very good idea. Okay, from what I have received from your lecturer, let me check here. Okay, yeah, okay. Okay, you are doing this nano encapsulation, correct?
Yes.
Yeah.
Okay, nano encapsulation. Smaller capsule size, easy to consume. Okay. Absorption process. Okay, that's why you want to do nanoparticle because it's easier to penetrate into our body system. Higher exposed surface area, correct? Okay, very good. So you can go far. But as I mentioned, before you want to do any prototype or you want to do any testing, again, toxicology test is very important. Okay, toxicology test in vivo, in vitro is one of the type lah. Not only that, if you are, if this one I look into your question and also your introduction, you are doing nano emulsion. You want to do nano emulsion, am I correct?
Yeah.
Yes.
Okay, nano emulsion. Okay. My one of my expertise is actually nano emulsion. Okay, nanocellulose for nano emulsion. When we talk about nano emulsion, there is by right there is a lot of phase and there is a lot of type. So one of the type is actually water in oil and oil in water. So you have to select properly which phase and which type that you want to do. From there, you can modify hydrophobic or hydrophilic of your surface area of your capsule or your particles. Then only you can go to the next step. Okay?
Right. So talking about nano emulsions, could doctor give us some opinion about this? Is it a good idea to continue with it?
It's a good idea. It's a good idea. So far, not so much lah, up to my knowledge. It's actually a very good idea. Please proceed. But as I mentioned, there's a lot of research part that you really want to venture into it.
All right. So can you please proceed with your question?
If we are talking about nano emulsions and nanoparticles, do you think it could be sustainable for the environment?
Environment. Okay. May I know what is actually your raw material that you want to do for your nano emulsion or your encapsulation?
Our
Chitosan, right?
encapsulation, yes, Shito-san.
Chitosan. Okay. Chitosan derived from where?
The shell of sea animals like prawns.
Okay, very good lah, like prawns. Sustainability, by right, it is actually a good idea. But I think from my perspective, yes, you can proceed with that lah, prawn, because as you know, Malaysia is actually one of a country that a lot of shell that we produce, and normally we discard away just like that. So in terms of recyclability, in terms of sustainability and renewability, yeah, I agree with that.
When we are developing the nano-enhanced electrolyte, do you think it could be expensive for us to develop it?
Okay, when we talk about expensive, okay, first you have two scale normally when we do R&D. First is lab scale, second is industrial scale. Okay, obviously for R&D, for the first part is actually lab scale. Okay, then you have to look into your budget. Okay, how much that you want to propose and you want to put inside there. Number one. Number two, just now, correct me if I'm wrong, you are deriving chitosan from your prawn skin, correct?
Yes, correct.
Okay, first things first, where you want to find that prawn skin? Okay, where? From where? Okay, second, let's say you get from market and whatsoever. Is there any continuous supply from that market? You have to know in maybe 2 years or even 2 months. Number three, chitosan. Okay, so you have to know when we talk about chitosan, okay, it's actually it depends on environment. Okay, your nutrient, your chitosan content depend on the environment and also depend on what kind of prawn that you derive. So let's say you take prawn type A, okay, and then suddenly next 2 months you take prawn type B. Is your chitosan content will be the same? And that is one of the aspect you need to consider. Okay, so that's why I said to you, if you want to make it as a real project, you have to make sure where is your supply and will it continue to supply to you with the same prawn for the how long that you want to take. Will it give you to you the same prawn? So that's why lah you have to look into that.
if we are talking about chitosan, is there any other alternative for us to make it as a capsule? So that means other than chitosan, what can we use?
Okay, other than chitosan for capsule Okay, give me a moment. Let me check. Okay, chitosan correct lah. Chitosan is one of the carbohydrate. Okay, when we talk about carbohydrate, you have a lot of carbohydrate. Okay, so carbohydrate is actually one of the polymer. Okay, so a part of chitosan, which is actually edible, probably maybe you can use another one, which is actually nanocellulose. You can also use that. But nanocellulose, if you want to use that, you really need to functionalize your functional group at your surface area, because that is actually my specialty lah. I'm a nanocellulose, nano-emulsion. Because cellulose human cannot consume. But the beauty of nanocellulose is actually we derive from plant. Okay, we can derive from plant, we can derive from food. Okay, so the feedstock is more easier. Okay, but however, again, I want to tell you, if you want to functionalize your functional group of your hydroxyl at that particular polymer, you really need to functionalize properly so that human can consume. Okay, understand? But
So
okay,
is there
then
any other questions?
from your end?
If there's no, then maybe there's like an advice that we would like to say to our team so that we can improve furthermore our research.
Okay, your research is very good. Chitosan is a very good thing, but as I mentioned to you now, my advice is actually, if you want to do nano emulsion, what phase that you want to do lah, all in water or water in oil. Okay, second, your feedstock of your chitosan, let's say you derive from a prawn skin. Okay, is your supply going to be continuous for how many long? Because chitosan one of the carbohydrate. When we talk about carbohydrate, it's actually a polymer. So obviously when we talk about any living system, the content will be different from one species to the other species. Maybe not so much, but there is some difference. So you have to take note into that. Okay, and then thirdly, in terms of costing, okay, let's say you want to do this as a real project. It's a very good project. I did admit, and very good clap to you all. Okay, but if let's say you want to do as a real project, please forecast for lab scale how much that you want to spend, and if you want to upscale to industry, how much that you want to spend. Okay, in terms of sustainability so far now, from theoretical aspect, it is sustainable, renewable, recyclable. But in terms of real life, then you have to venture out lah, what I said about raw material and what kind of chemical that you are using. Okay, let's say you say green. Okay, you are claiming about green technology. You have to know, green technology, you have to be careful in terms of term, or in terms of that term itself. Green means less waste. Okay, let's say you want to, what we call it, bleach, okay, your sample. Okay, bleaching, you have a lot of type. Sodium chloride, hydrogen peroxide, H2O2, and a lot. Okay, so what kind of chemical that you want to select? From my perspective, the greenest one is actually hydrogen peroxide. Because if you want to use hydrogen peroxide, even if you expose in a normal condition, it can turn to H2O. So lesser chemical. But sodium chloride is different thing. Probably it can produce some kind of waste system lah, chlorine whatsoever. So it's actually more corrosive towards industry and also to environment. That kind of thing you have to consider the production. And then production also, there's a chemical type, physical type, mechanical type. So you have to choose all of this if you want to do this as a real project. Okay? I hope I give some input to you lah.
Is there any more questions from Sue or teacher?
I think I'm
Thank you so much.
Okay.